Hello, everyone, and welcome to today's Tech Talk on boiler systems commissioning, installation, and operation considerations. My name is Sherry Adams, and I'll be the moderator for today's session. Please note that throughout the Tech Talk, all phone lines will be muted. This will minimize any background noise or feedback that could distract from the presentation. When you first joined the Tech Talk, an attendee control panel appeared on the right side of your desktop. On the left side of this control panel is a small tab with an arrow icon at the top. Pressing this icon allows you to minimize and maximize the control panel. When maximized, you can use the control panel to submit questions. We'll be gathering questions throughout the Tech Talk, and we'll leave a little time at the end for Q&A. If your question is related to a particular slide, please include the number of that slide in your question. A PDF of the slides from this presentation will be sent electronically to all those who are registered for today's Tech Talk. We'll also be recording it, and it will be available on our website under the resource section. The current password to access the Tech Talks is TechTalks18. That's capital T-E-C-H, capital T-A-L-K-S-18. Today's presenter is Carrie Donovan. Carrie is currently the Secretary for the BCA National Capital Chapter. She is working principal and president of Precise Commissioning. She is a mechanical engineer with over 16 years of professional experience. She holds a professional engineering license in 6 states. She's worked on projects including central utility plants, clean rooms, laboratories, data centers, vivariums, hospitals, and pharmaceutical facilities. Her area of expertise is the design and commissioning of critical HVAC systems with precision temperature and systems controls. Carrie is proficient in plant equipment requirements, specific control sequences commissioning, and testing and balancing support. In addition to mechanical engineering design, Carrie is actively engaged with clients throughout project management. She has completed projects for a variety of clients, including Merck, GSK, Dow Chemical Company, Drexel University, Penn State, and several others. So Carrie, I will turn this Tech Talk over to you now.
Great, thanks, Sherry. So today's topic is boiler systems commissioning, and the goal here is really just to provide some of the breadcrumbs to get you started for a commissioning process. Obviously, this is a rather large topic, and we can't get too far into the weeds. But we do want to start at the beginning, that if we were lucky enough to be brought on at the beginning of the project instead of at the end, where we often are brought in at construction, we want to kind of walk through this, how we would approach this. So for any system that we were going to do, we're going to go through this agenda. We'll go through codes and standards, boiler system loads and pairing, hot water systems and steam systems, their support components, functional testing considerations, the boiler room in general, and then we'll end up with some Q&A like Sherry said. So when commissioning any piece of equipment or system, it's important to start with an understanding of the applicable codes and standards. This includes down to the state and local levels to incorporate requirements of the authority having jurisdiction, or the AHJ. Specific to boilers, we'll refer to the ASME, Boiler and Pressure Vessel Code, which outlines the rules for design, fabrication, and inspection of boilers and pressure vessels. The code is divided into multiple sections. Relevant to today's topic are Section 1 for power boilers, Section 4 for heating boilers, and Section 8 for pressure vessels. Equipment that falls under this code must have an ASME stamp. After the first edition of the code in 1914, there needed to be a verification that boilers were being manufactured according to the newly established code. This verification was executed by independent inspectors, who in turn offered different interpretation of that code. As a result, the National Board of Boiler and Pressure Vessel Inspectors was formed. This group is composed of chief boiler vessel inspectors representing states, cities, provinces enforcing pressure equipment laws and regulations. So this board created the National Board Inspection Code, which is a consensus document and a standard that has been adopted by most cities and states, and also federal regulatory agencies. It addresses the standards for installation, inspection, and repair or alteration of the boilers, pressure vessels, and pressure relief devices. This document is a great resource. Boiler safeties and controls, often referred to as boiler trim, fall under the ASME CSD1. Additional requirements may be dictated by that facility's insurance carrier, and these can include a UL, ULC, CSA, or CGA listing, and additional devices on the boiler trim. For this reason, it is important that the engineer of record has identified the applicable insurance carrier requirements and that these items are commissioned. For boilers 12.5 million BTU per hour and over, NFPA 85, which is the Boiler and Combustion Systems Hazard Code, will govern. One of the first things we need to verify when we get involved in a boiler project is to verify that the boiler system is appropriately paired for the facility loads and the intended use. Load types include comfort heating, manufacturing process, or intermittent use, such as a kitchen or a dry cleaning facility. In general, for the comfort heating, we'll see hot water boilers or low pressure steam boiler systems, 15 psi and lower. For process loads, which could be batch or continuous, they'll often require a high pressure steam boiler system. The load can also be a combination, requiring pressure reducing stations that can adjust the steam pressure for the intended use. When we're fortunate enough to be brought in the early design of a process commissioning as commissioning agents, we're able to review the intended overall boiler system operation, including peak and low demands and boiler selection, staging intentions, and if there will be redundancy in the systems and the support available from the owner's personnel once that equipment is put into operation. You need to review the documents for the intended control type of the multiple boiler systems. Will it be an on-off cycling type control, high fire, low fire control, or more commonly in large plants, modulating control? So as we move into hot water systems, this diagram really only depicts those major components of a hot water boiler system, but it does not address all system equipment such as air separators, expansion tanks, and safety devices. Air removal of these systems is key, not just at the air separator, but also at the boiler itself. The boiler and the expansion tank should be located at the suction side of the pump in any pumping mechanism. For the purposes of this component review, we'll not be getting into all the different pumping and valving arrangements. However, there are a few items to verify no matter the pumping arrangement to ensure proper operation. So for installation considerations for the hot water boiler system, one of the first things we would look at is if the system is a hot water system or is it a glycol mix solution. If the system requires a glycol solution, such as preheating a low outside air temperature, it's important to make sure that the makeup water line is not directly connected to the system, because glycol contributes to the chemical treatment of the system by acting as a biocide, or really like a biostatic solution. Makeup for these systems should come from a premix solution, and chemical treatment should be handled from a separate shot feeder. If the project team decides that instead of purchasing premix solution to do the initial fill of that system, and instead to calculate the volume of the system and then mix water and 100% glycol in that system, be very certain that there are no isolated sections of that system where the solution could not get mixed. We were actually on a project where the owner decided that they would take that on themselves, and against recommendations for the entire project team, decided to attempt this mixing. It actually resulted in ruptured coils as some of the three-way valves were not ever modulated throughout that mixing process. In addition, make sure that the reliefs and the drains from the expansion tank and air separator are taken to a glycol tank and not to drain. In a multiple boiler system, you want to verify that there are means to hydraulically balance and isolate equipment to maintain minimum flow rates through those boilers. And if you have a system with condensing boilers, verify that there's a dealkalizer provided on the drain and that the boiler flue is made of stainless or plastic, not galvanized. For operational considerations, you really want to pay special attention to reviewing the sequence of operation and the valving positions and pump speeds. Is the system a primary, secondary pumping arrangement? Are there three-way valves at all the loads, or do you have a differential bypass? No matter the arrangement, we need to verify that through all modes of staging and operation, there is a method to maintain a minimum flow rate of approximately 1 GPM per boiler horsepower for each boiler in all modes of operation. When bringing a second colder boiler online, verify that there is a means to limit that temperature increase of the boiler to no more than 1 degree F per minute. This includes maintaining that burner in a low fire condition for a minimum of 30 minutes while it warms up. If the system has condensing boilers, verify that the temperature requirements of the connected load are in alignment with the operation range for a condensing boiler to operate efficiently. These boilers operate best with low return water temperatures and leaving water temperatures under 130 degrees F. We have seen owners trying to capitalize on these efficiencies only to find that their installed systems are not compatible with those reduced temperatures. If we move over to the steam boiler system, this diagram depicts major components of the steam boiler system: feed water, fuel, steam supply, boiler, and the controls. We've addressed the importance of pairing the boiler and load type earlier, so we'll move through the remaining components, such as blowdown and feed water systems. As with any steam and condensate system, appropriate pitching of the piping is imperative to the system functionality. The piping around the steam boiler is no different. Boiler blowdown happens at the bottom of the boiler to remove dissolved solids from the vessel. This piping is therefore low to the ground and needs to be directed to a safe point of discharge. The routing and sizing of this piping needs to be coordinated with its distance from that discharge location, as well as reviewed for a tripping hazard within the boiler room. Trenching can be incorporated to accommodate this routing in a safe manner. Also verify that there's a floor sink and not a floor drain installed below the blowdown separator to be able to handle the amount of volume of water without overwhelming a regular floor drain. Verify that the steam header takeoffs are made from the top of the header. It seems obvious, but they should really look like candy canes. Verify that the reducers and strainers are installed in the correct orientation for the application. Strainers will appear to be installed sideways from a hydronic system, and couplings should be eccentric with the flat side on the bottom. Verify that the engineer has accounted for expansion in the piping system, and if expansion loops are required. Verify locations of vacuum breakers on the equipment during your walkdowns. Verify that the deaerator type is compatible with the steam use and the pressure for the condensate return system. We've actually seen backups in the system that can appear elsewhere due to high back pressure on a condensate return system at the DA. Also review the sequencing of boiler feed water booster pumps from that DA. Are they one pump per boiler, or are they set up for a more manifold operation? And for those process critical installations, sometimes you'll see an engineer put in a header connection for a temporary boiler to roll up and feed the system with the necessary isolation components. Make sure you look at those isolation components across all systems. From an operational side, you really want to make sure that if you have electric condensate pumps out in the system that are utilized to return condensate to the boilers from those remote locations, that they're available on that same power. And for instance, if your boilers are expected to operate on emergency power, make sure those condensate pumps are also on emergency power and available at the same time. Otherwise, you will have backups in the system. This also applies to the other supporting systems, such as fans, damper actuators, etc. Verify that there's a relief valve downstream of each pressure reducing valve in your pressure reducing station, and that it is appropriately vented. The valve should not have any isolation valves between it and the load, and it should also be located so it could pick up a bypass. Review all set pressures of safety relief devices against the documents and downstream equipment, and document their settings in your installation checks. Review the operation for the type of pressure reducing valve and that there is sufficient length in the pressure reducing station to limit velocity across those valve feeds. Each branch should be equipped with pre and post pressure gauges. Infrared temperature guns can also be utilized to troubleshoot steam traps that happen to be passing. For boiler blowdown, it's required to keep the amount of total dissolved solids, including dissolved, suspended solids, and sludge present in the boiler water within acceptable ranges. Systems that operate with higher rates of condensate return will require less frequent boiler blowdown than systems that bring in higher amounts of makeup water. The makeup water source and treatment will also play a role in the blowdown frequency, with softened water preferred to hard water sources. 1,000 parts per million is a recognized rule of thumb for maximum concentrations in your system. Boiler blowdown can be manual or automatic and is part of the operation and preventive maintenance of the boiler system. Continuous automatic blowdown takes place at the boiler water surface by a calibrated valve at a predetermined rate based on the water quality. This rate can change seasonally, not only based on the municipal water sources, but also if used for humidification loads, where additional makeup will be required during those dry winters. Manual blowdown occurs at the bottom of the boiler and keeps the water level control devices and cutoff devices clean of solids and sludge that will eventually build up. Generally, the operator will use the quick opening and slow opening valves to lower the level in the sight glass about a half an inch, or is determined by their water treatment results. So when you're doing your system walkdowns, check to see that the operator is able to see the sight glass from both of those valves. If so, they can accomplish this blowdown as a single operator. Otherwise, 2 people will be required. The blowdown piping will go to a blowdown separator. Make sure that blowdown separator is vented to a safe location to prevent the uncontrolled flashing of steam, and that a blowdown aftercooler is provided at that floor sink location we talked about earlier to bring the blowdown water temperature to acceptable levels and to discharge to that sewer system. And as adding chemicals to the system is costly, it's preferred to minimize blowdown activities, which then will require additional chemical treatment for the makeup water. So speaking about boiler feed water, your feed water is made up of condensate return, treated makeup water, and deaerator steam. The boiler feed water treatment includes removal of oxygen and dissolved gases. Evidence of these gases can result in corrosion, leading to equipment and piping failures. Condensate systems are often affected by carbon dioxide that turns into carbonic acid. Dissolved oxygen in the system can be removed by utilizing a deaerator feed tank, heated feed water, or treating the feed water in a condensate tank. Introducing an oxygen scavenger into the feed water system will also help remove dissolved oxygen in the feed water. The amount of oxygen absorbed in the water is proportional to temperature and pressure, so signs of oxygen corrosion are often found in wet stored boilers and feed water tanks that have a prolonged cooler temperature. For your boiler feed water temperature consideration, every 10-degree F drop in feed water temperature leads to a 1% loss in boiler efficiency. So you really want to look at a system that can return as much hot condensate as possible to the boiler. This also assists with that chemical treatment cost we talked about earlier. Another way to pick up energy for your feed water is to provide a stack economizer to transfer heat from the boiler vent stack to the boiler system itself. The support system components of the boiler system will be governed by NFPA 54, which is the National Fuel Gas Code, and NFPA 31, which covers oil burning equipment. Combustion and ventilation air are required in your boiler room, and sufficient air intakes are required to complete combustion, but also to minimize the possibility of a furnace explosion. Where combustion air is provided by louvers with dampers on them, the resulting free area needs to be verified with the installed equipment in the room, not just the boilers, but all other fuel burning appliances as well. These intake openings will be located high and low on the exterior walls. Verify that these openings are not blocked by storage in the mechanical room or debris such as leaves outside. Operation of the dampers, or in some cases a mechanical ventilation unit, must be interlocked with the operation of the burner so that the burner will not fire unless the dampers are proven open or airflow is proved. In larger boiler rooms where there's a significant air requirement, verify there is a means of maintaining areas of the room above freezing, such as the use of unit heaters. Boiler venting. Boiler exhaust venting is determined by the pressure and temperature produced in the exhaust stack. Common venting of boilers is acceptable for negative pressure stacks, whereas positive pressure stacks must be individually vented. In your checks, check to see that a boiler vent stack vendor submittal has been approved and calculations pertaining to the system boiler type and capacities have been provided and installed accordingly during your commissioning walkdowns. Also, it's important to review the use of exhaust fans in the space to pull air through louvers in the summer to relieve heat from the room. Make sure there's a control loop in the BAS to maintain the mechanical space above negative pressure, and a way to verify that the boiler room receives sufficient combustion air to minimize the possibility of high concentrations of carbon monoxide. Fuel systems. Boilers can have multiple fuel sources. The most straightforward and efficient would be a small electric Sussman type boiler hooked up to maybe a lab autoclave. But we often see larger systems with natural gas, propane, and fuel oil. And some boilers are provided with dual fuel or combination burners, either to take advantage of off-peak fuel pricing or for reliability of the fuel source. When the boiler system feeds critical loads, the functional testing of both fuel sources as well as the switchover from one source to another is important to prove. The system may require a double block and vent valve on the gas train as a safety for potential upstream leaking of fuel into the burner when the burner is not in operation. Make sure that is vented to a safe location. And remember that each boiler requires its own manual fuel isolation valve. Water treatment is so important in steam systems. For most of the systems we commission, troubleshooting usually comes down to controls issues. But with boiler systems, it's controls and water treatment issues. Water treatment really impacts the operation, efficiency, and service life of the equipment. As hot water systems are generally closed-loop systems, the water chemistry is fairly straightforward and is treated during the initial fill. Periodic checks and minor modifications will be required to maintain that loop. For this reason, makeup water connections should include a meter to assist with water treatment and system troubleshooting, as this may be the only way to identify a loss of water on that system. These systems can be automatic, or when there's a full-time boiler operator, they can be a manual indicator handled through a low water alarm, maybe in the expansion tank. Realize that in steam systems with combination loads, the portion of return condensate in the overall feed water will change seasonally, as humidification loads will increase the amount of makeup and chemical treatment required. Makeup water should be pre-treated either by softening, ion exchange, or some have even reverse osmosis systems to remove scale-forming minerals. Because of the importance of chemical treatment in the operation of the system, verify that the water treatment vendor has developed a water treatment service program and that detailed training is conducted with the on-site staff. Monitoring the boiler water is important to the operation and longevity of the boiler plant. Sampling valves are required for the boiler operator to be able to take samples and readings to verify proper operation of the system and carry out proper chemical treatment activities. This should be done at room temperature for safety. Verify that there are sample coolers in place and that they are in working order. In working in boiler systems, we're really looking at controlling water flow, airflow, and fuel. The safety interlocks are for personnel, safety, and equipment protection, and shut down the equipment on abnormal temperature, pressure, or loss of combustion airflow. The safety devices are wired through the burner controller to interlock the safeties with the fuel supply to the burner. These safety interlocks must be manually reset after the cause of a failure has been identified and corrected. Verify that relief valves for water boilers or safety valves for steam boilers are installed with drip pan elbows under them and that they include a drain routed to the floor. No other type of shutoff valve should be installed in the relief valve discharge piping, and the routing should be as direct of a route as possible to a safe discharge location to the exterior for steam boilers over 500 pounds per hour. This line should not contain 90-degree elbows. Isometrics may be required to confirm calculations if a difficult route of discharge piping is required in a boiler room. If those are provided, walk down those isometrics in the field. Water level control is critical to the operation of the boiler. In steam systems, this is handled by maintaining the water level in the drum. Visual inspection is made by the operator at the gauge glass, with normal operating water level approximately in the middle of that glass. Steam boilers require two methods for determining boiler water level. So if a gauge glass is not functional, the tricox located on the water column will be used. For these to remain functional, proper blowdown operations are required to periodically remove sludge, sediment, or scale. Hot water boilers, it's desirable to interlock the pump with the burner so that the boiler will not fire without water circulation. Adequate water flow through the boiler needs to be controlled. So check for either a flow measuring device, or if your building automation system has a simple difference between the entering and leaving water temperature of the boiler. Make sure whichever method is used, it's identified on the control drawings and proven during your testing. Hot water boilers will have a high temperature safety switch, which will require a manual reset. There should be no valves isolating it from the water boiler. Steam boilers will have a high pressure switch, which will require manual reset. Again, verify no valves isolate it from the boiler's internal pressure. Verify that there's adequate fuel pressure. Additional fuel train requirements that may be dictated by that facility's insurance carrier or underwriter may require an increase in fuel pressure from the source to overcome pressure losses for those additional components in your fuel train. Since the instruments on the system are providing data back to the controllers, it's important that they are properly located and calibrated. Request calibration certificates for these devices during your commissioning. So we get to startup. Hydrostatic testing of the boiler itself will have been performed at the factory, and you should be able to have copies of the test and the witness signature on those copies. The installed system will then also be hydrostatically tested prior to startup, and this will be witnessed by the authority having jurisdiction. New boilers will undergo a boil out or an initial chemical cleaning to remove grease and oils left over from the boiler's fabrication. This is often a combined effort between the mechanical contractor and the vendor. Boil out of a new unit, as well as cleaning of the system piping, needs to be included in the overall startup schedule with the CM and will occur after the AHJ or the boiler inspector has reviewed the installation. If the boiler will undergo boil out, verify that the installation of the overflow pipe is installed and it is routed to a safe discharge location. The chemical treatment provider should be involved at this point and begin to manage the water chemistry right from that initial fill. You want to verify operation of the combustion and ventilation air system on the boiler startup and shutdown. And verify operating gear such as chain wheels are attached to all specified valves to allow operation, including emergency isolation, without the need of a ladder or climbing or safety gear. You'll review the startup and shutdown checklists executed by the vendor and the contractors prior to moving to functional testing. Review the engineer's punch list and make sure there are no open items and that both the air and the water side testing and balancing has occurred. For functional testing, verify that the supporting systems have already been commissioned and are ready to support the testing of the boiler equipment. This includes a fuel oil system, combustion air systems, and condensate pumps, water softening equipment. Start all the circulator pumps individually to check for operational issues and ramp them if they're on VFDs. Check all valve and damper actuation before starting the functional testing. Including your functional testing documents interlocks with non-manufacturer provided controls, such as intake dampers or combustion air fans or pumps. Verify that dual fuel systems are tested in both operating scenarios and manual transfer and alarming is included. Multiple boiler installations should have a master boiler control panel, which allows for on-off auto functionality of multiple boiler and automatic transition for lead lag and boiler selection. Even with this master control panel, boilers should still have their own local boiler control panel for manual operation upon the loss of the master. Verify this operation during testing, including the loss of the master, that the boilers are able to run on their own control panels. Verify that automatic isolation valves are installed and operate correctly. Verify proper boiler staging under normal operation, as well as under all failure and emergency operating modes, especially if multiple units are installed which are unequal in size. Close coordination between boiler staging and actual load will minimize energy usage in the operating plant. Verify that the boilers and primary feed water pumps stage up and down per the sequence of operations under all operating modes. And verify that all control loops stabilize within a reasonable amount of time, typically 2 to 5 minutes, after a significant load change out in the system, such as startup or automatic manual recovery from shutdown. For the steam systems, verify the pressure at the steam header at each leg of the PRV station for knockdown pressures, and also look if there are any critical use points out in the system. Prepare test protocols for staging the boilers and for isolation, again, focusing on controlling water, air, and fuel. You want to make sure you test down the shutdown scenarios as well. For water systems, there's a system flywheel effect that needs to be accounted for in the control logic, as changes in boiler leaving water temperature will not necessarily result in an immediate change out in the system of your entering water temperature at the system loads, and you don't want your systems to be hunting. Verify adequate time delays between equipment start-stop commands and system isolation. Verify temperature reset schedules ramp equipment appropriately. Review ability to test redundancy and partial load conditions prior to testing. These could lead to additional feasible testing requirements. We've actually run into a condition while doing core and shell buildings where there's actually not enough core load on the system to test a heating hot water system when all the VAV reheats in a tenant fit out were not installed yet. Remote audio and visual alarms for high pressure cutout switches should also be tested, and verify that the engineer of record has identified on the contract documents which control points will be monitored versus controlled by a building automation system, and what alarms will be sent from the boiler control panel and at what criticality level to what reporting device. We want to take a look at the boiler room in general. First and foremost, the boiler room often becomes that junk drawer of the facility, an all-purpose storage area. Well, this can sometimes be to our benefit. For instance, when we find those long misplaced as-built or equipment manuals, it's a safety issue for a room purpose-built for fuel-burning equipment. Verify that there's appropriate means of egress from the room. Larger boiler rooms should be equipped with 2 means of egress. Emergency burner boiler push buttons, shut-off switches, which are EPOs or emergency power-off buttons, should be installed at each exit door and will also require testing. Verify that there is adequate access for service and maintenance, as well as code-required clearances around the equipment. If the installation does not meet the code-required clearances, variances must be requested. Early identification of these variances by the commissioning agent is important to maintain project schedule. Clearances. Think ahead for the boiler replacement, or if you have a phased installation, that the doorways and aisleways are wide enough, and overhead piping allows for the removal of the boilers through the space and installation without impacting the remaining boiler systems in operation, or operation of other systems near the path of travel. Check to see that there's access for annual maintenance activities, such as cleaning tubes and tube sheets. Also review the isolation valves of piping around the boiler, so that the isolation itself can be isolated above the boiler and the boiler can be moved out underneath the piping. That way, one boiler can be removed without shutting down the rest of the system. Some other things to look for. Is the room programmed in such a way that there's adequate circulation for combustion air to the equipment? Is there chemical treatment area in the room? And is it appropriately outfit with containment and with a sink and a safety station nearby? And has a location been identified on the wall for a coupon rack? Is there a boiler operator area provided? And does it have visibility to the operating equipment and access to a restroom? Do sprinkler lines or other standing water lines, such as makeup water, run near those fresh air intakes, because they absolutely will freeze. And we want to take a look at all the closeout documentation. So we talked about the manufacturer's data report, startup reports, IO&M manuals, parts list and part numbers, and take a look at the fuel supply contract and the contact information and make sure that's available. You'll also be able to take a look at operating logbook and procedures. Make yourself familiar with the procedures for the boiler. It actually helps you write your checklist. Key players involved, not too different from any other system. You'll have your facility owner, your boiler operator, which may be hired by the facility owner or it could be a service company, the AE, the inspector or AHJ, the boiler manufacturer, your MEP contractors, VAS contractor, your chemical treatment vendor, and of course you as the commissioning authority. And that's what I got.
Thank you, Carrie. We really appreciate your time and expertise. Looks like we don't have any questions at the moment, but if you do have a question, you have time to ask one now. Really quickly, I have a couple of quick reminders, and so we'll see if we get something in while I review that we have an upcoming webinar scheduled for December 5th on a daylight review for commissioning providers. And also it's membership renewal time right around the corner, so keep an eye out for your renewal notices, both by mail and email, coming in the next couple of weeks. And it does look like we have a couple of questions, Carrie, so let me read them to you. Do you rely on manufacturer checklists for pre-startup confirmation of safety, or do you recommend the development of a project-specific pre-start checklist and I think it's sign-off sheets?
Sure. So, I mean, the best place to start is always from the manufacturer's installation and startup requirements. But we treat boiler systems and their trim almost like a P&ID, and we actually walk down every one. What you'll see from the manufacturer is that they have a generalized concept of what needs to be there, and that really needs to be put in place with how this boiler system in this facility is going to operate. So it's a great starting point, but we pretty much write them with that as a starting point and really make them job specific.
Great. Okay, we have another one. You mentioned glycol shot feeder early in the presentation. Are you referring to the questions are coming in fast. Okay, hold on. You mentioned shock feeder early in the presentation. Are you referring to the glycol metering system?
So if you go back to this, oops, hold on. Go back to this picture. I have it brought up here. So you want to have a point at which you can introduce those chemicals. I'm sorry, what was the question again?
Hold on, let me get to it because I skipped over one too.
Sorry.
No, it's okay.
Already moved on.
So you're on yes. So you mentioned the glycol shot feeder early in the presentation. Are you referring to the glycol metering system?
So it's a collection of the glycol that's a premixed solution where the expansion tank should be able to go to, and accompanied with that is your shot feeder. Because again, you don't want to be putting direct makeup air into that. So you'll be doing additional chemical treatment through that shot feeder.
Okay. And then are the eyewash statements on code required item for all boiler rooms?
So you've got to look at the hazard. I mean, honestly, what's going to come down to it is your industrial hygienist that's going to be on the project from the owner side. But anytime that you have like a caustic or some sort of a chemical treatment, it's good practice not only to have the sink, and I don't know if you saw the funny sink that got put into one of the jobs so that they could say they had one. Here, let me bring up that picture again. There you can see the little drum sink that they hooked up. So again, you're working with chemicals, so it's a good idea to have the eye wash and the safety station. From a code perspective, we usually end up falling towards making it a recommendation, and the industrial hygienist on that project is usually going to be the one that dictates whether or not they need to have something there or just a eye wash bottle that they can get to the next thing. But there's so many tripping hazards in a boiler room, it's good practice.
Okay, great. And then would you please verify the maximum discharge temperatures for both condensing and non-condensing boilers?
Maximum, you mean leaving water temperatures?
I'm just going off this question, so
yeah,
I need clarification.
So for condensing boilers for your maximum efficiency, they don't run hot. So really around 130 degrees is really kind of your maximum where you get your peak efficiency for a condensing boiler system. The trouble that we've seen is owners see, oh, this is a great efficient boiler, this is what I want, but their systems are all designed for 180 degree entering water temperatures.
Okay. And then another question, any pointers for Corps of Engineers and or Veterans Administration testing?
I don't think I have anything for that.
Okay, and here's another one. How do you handle OSHA's process safety management requirements prior to startup? In particular, are there pre-startup review checklists available that cover all the issues and pitfalls you mentioned in the presentation?
Are there checklists from OSHA? Is that the question?
How do you handle OSHA's process safety management requirements prior to startup? In particular, are there pre-startup review checklists available that cover all the issues and pitfalls that you had mentioned?
So I can tell you, we work a lot in larger facilities where we'll actually go through a HAZOP or an ESI, so an equipment safety installation check, where we'll actually walk through all these items. And we will check all of the safeties that are listed for the boiler, and we will pull each one of them, trip each one individually, make sure it resets before you trip the next one. So the projects that we work on are a more formalized process internal to the owner's organization. So I have never actually gone to look to see if there's actually something written down or available, kind of pre-generated elsewhere. But I could look into that.
Okay, great. And it looks like we have a couple more, and we'll try to get to a couple more. If you're okay, Carrie, and then we might have to take some of these offline. But do you typically test all of the bells and whistles that are packaged with the boiler, or rely on evidence in startup report?
So it depends on what it is. So for instance, we want to make sure that the high water and the low water cutoff work. We want to make sure that if we kill the fuel system, or if we trip if we have a ventilating unit that's providing that makeup air, or an actual mechanical unit that's providing that combustion air, we want to make sure that those actually trip. So yes, you will be able to leverage some of that. And part of it, sometimes we'll almost call an audible, I would say, when your startup report looks like it came back and it was really through the motions, you generally go back through and do a more thorough testing. We've had some manufacturers come out and they really do a very thorough. We like to be there on site during that startup process, because then we can kind of see what's happening with how the system is operating, or how the boiler itself is operating, before we go and test the full system. So there are certain interlocks that we absolutely will check, and again, by killing other systems that would trigger them. But a lot of what's going to happen is how thorough that startup process was, and do we feel comfortable with that documentation.
Great. And then if we could do this one last question, can you talk about the limitations of controlling using the manufacturer's control panel versus the BMCS?
Sure. I actually have an interesting, we're working on a project right now where the engineer of record asked for a complete PLC-based boiler control system. The manufacturer did not provide that. The contractor did not price that. And so for the last 3 months, we've been going round and round trying to identify what was the real intent of the system. Can we achieve that with standard boiler control panels and burners, with a master controller? So really, the advice that I have is to make sure that, number one, hopefully you are involved in the project early enough that you can get into that design review. We very rarely see drawings come through that don't have a detailed sequence of operation, a fully spec'd out boiler control panel system, and the points that need to be monitored. And again, it's kind of the level of the projects that we tend to find ourselves on with these boilers. However, some smaller projects, you will see that. So the best thing is to really just send those RFIs in early and request, because you can't write your functional testing document when it's unclear from the engineer how they intended for these pieces and parts to work together from the very beginning, and they end up relying on the manufacturer, who could send a different startup tech and set it up differently out of whim. So it's got to be documented at the beginning, or you're checking against nothing. You're checking that it works, but you don't know if it works the way it was intended to.
Great. Well, thank you so much, Carrie. We really, again, appreciate your time and expertise. And if anybody didn't get a question answered, please feel free to send an email to me. And if Carrie, if you're fine with that, we'll forward it to you to answer offline. But again, thank you. And on behalf of BCA, I would like to thank everyone for your participation today in today's Tech Talk, and have a great day. Thank you.
Thanks.